Hello. Thanks for tuning in. So, it's Thursday, and hello. And it's a long weekend for me, so I think the plan is I'm gonna go through RevisionVillage's free exam for SL, their paper 2. I went through their paper 1 already. And this shouldn't take too long because it's SL. And if there's time, because I might get people asking me for help on chat, then maybe I can play a little bit of Baba Is You again. But anyways, so I guess you can call this a speed run. But I don't know, it's Thursday. I can think of at least one person that might have a bunch of questions for me. And my actual students have a test on Tuesday, so who knows, they might be bugging me this stream and also next stream for help. But anyways, okay. So here's the first question. We have a school conducting research into how many minutes each day their students spend browsing the internet. And then Jake's class is studied first. Here are the number of minutes of each student represented in a stem and leaf plot. Man, I hate stem and leaf plots. So basically, the stem, well, they give you an example of how it works. 2, and then if the stem is 2 and the leaf is 3, then that represents 23 minutes. I mean, I guess it's efficient, but it's so, like, I don't think it makes it any better to read. So for example, this means that for the students, the times of each student spending on the internet are as followed. So basically it's 10, 1 and 0, 14 and 18, and then all of these. And you're gonna have to write this out anyways, so I don't see the point in the stem and leaf plot. I'm sure like graphing calculators have a way to work with stem and leaf plots, but you know, that's some pretty arbitrary information, and like you already have to memorize so much, so I never promote memorizing extra calculator functions unless they're super useful. Okay, completely unrealistic times. Some student only spends 10 minutes on the internet a day. But anyways, so here are all the times, and then what does it say? Write down the number of students in his class. Well, that's just how many entries there are. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 students. And then we need to find the median number. So of course this is just the average, so we're gonna add all of these up and then divide by 16. And this is why this is a paper 2. How can I turn off the history? Oh well. Alright, so time to get adding. 10 plus 14 plus 18 plus 23 plus 25 plus 28 plus 29 plus 31 plus 33 plus 33, 36, 36, 38, 40, 44, 45. Man, do you guys know about the bankers that can like type numbers really fast? I wish I could do that. Okay, so our median time is just a little over half an hour on the internet. I don't know when this paper was made because that's BS. So let's see, 30.2. Or wait a minute. Oh shoot. I just threw out all my credibility as a math teacher. Median is not the average, that's the mean. ignore everything I just said. And for those that are watching, I hope you didn't, like watching the VOD afterwards, I hope you didn't just quit on me because of such a rookie mistake. Okay, if there's 16 students, then the median is in between the 8th and 9th student. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. So right here is the median, which is 32. My bad. Okay. And then here's our box and whisker plot, and then we need to determine the value of Q. So box and whisker plot, the outer whiskers are the smallest and largest entries. The middle one is your median, and then the end of your boxes are your first and third quartiles. So finding Q first, that's just the largest amount of time spent on the internet, which is 45. Next up, we know that the interquartile range is 13. Find the value of P. So the interquartile range is the distance between the first quartile and the second quartile. Not second, third quartile. So if I know that that's 13, then I can just take 37, subtract 13. So P is 24. And that makes sense, right? If you have 16 students, the first quartile is going to be after 4 students, right? 1, 2, 3, 4, something like that. Anyways, let's keep going. Yeah, so you see after 4 students, you have the first quartile, which is exactly at 24. Where did that question disappear to? Oh, that was the third one. Okay, second one. So we have some sort of data table relating temperature to cans. And then we need to make a linear regression. So I need to get my GDC. So how does this work? I think you press second and then you go to stat to get the list. No, that just lets you edit it. Was it just stats? Okay, yeah. Stat button, and then you edit your lists. And then by default, the first list is normally your X value or your dependent variable, and then your second is your dependent, but it doesn't have to be that way. But anyways, let's just add in these numbers. Actually, first we should clear the list and then add our numbers in. So 5, 6, 18, 32, 29, and then 12. Okay, bullet lightning. Should I do math packages first or RevisionVillage review first? Depends on the amount of time you have, right? Because the packages are more in depth because there's more questions for each topic, and then RevisionVillage review that I gave you guys, you know, there's still quite a bit, but there's less questions for each subject. So it's like sort of more efficient, but you don't go into depth. Here's the one I was expecting. Hello. I'm assuming you have a lot of questions today. Anyways, okay, so let's add the second list in. Now that we have my list, I can calculate a linear regression. Your assignment is due tomorrow. Okay, you try it on your own. Okay, and then you can see in the TI-84 you can choose what's going to be your dependent and independent variable. Of course, we want this to be the other way around. Silasness, thanks. So calculate this, and then here's your A and B value. So 0.702 and then 22.9. Thus, estimate the number of soda cans purchased when the temperature is 23. So of course, we just put 23 into this equation for our linear regression. So 0.702 times 23 plus 22.9. So the number of soda cans is 39. And then we need to find the value of R, which is the correlation coefficient. That should have popped up when we did our linear regression. And if it doesn't, then you're going to need to turn it on in your settings. So let's see, mode. And then if we go down to the bottom, we have stat diagnostics. So we can turn this on. So when I do my linear regression again, here's the correlation coefficient, 0.931. And then if they were to ask you something about this, then this is a very strong correlation. Anything close to 1 is very good. And of course it's positive 1, so it's almost like a straight line. Okay. This is the one that I saw that I thought was question 2. Some good old binomial expansion. So find the third term in this expansion, find the possible values of what P is going to be. Okay, so for the general term, this is in your formula book. You have NCR, and then if you wanted to expand this out, a to the power of n minus r times b to the power of r. Hello, I'm not 5 a.m. So we do know a couple of things. One, a is x, and I want to find this for when x is to the power 6. This is the only contributing factor to what power of x you have in your term. Like p, I'm assuming, is an integer. So in other words, right away, I know a couple of things. This needs to be x to the power 6. And then I know n is 8, so that means that r has to be 2. In other words, I have 8c2, and then I have p to the power of 2 here. Okay. So if I'm just comparing the coefficients, right? I need 256 to be NC2 times p squared. Oh, 252. Okay, and then we can just use a calculator to figure this out. So I think it's under math, and then you go to probability, and it's right here. So 8 C2, so 28. And then of course, this means that P is going to be plus or minus the square root of 252 divided by 28. So we can just figure out what this is going to be. Hopefully it's nice numbers. No, it's not. Well, okay, screw you guys, I guess. Plus or minus root 14. Oh wait, I divide by 18. Let me try this again. 9, there you go. Plus or minus 3. Okay, next up. We have a particle that moves along a straight line, and then here's its velocity function. Find when the particle is at rest. Well, things are at rest when they're not moving. In other words, their velocity is 0. So I need to find out when this is equal to 0. Okay, so we can solve this using logarithms, but because this is a GDC question, I can just graph the function itself and then find out where the velocity is 0 from there. So 1.5 to the power of my variable minus 4.9. And then my window is probably all messed up from before, last time I used it. So let me just fix it. So this is where it's going to be at rest, and we can just calculate that. So here we are, 3.92. Next up, find the acceleration of the particle when t is 3. So if we have the velocity function, then if I take the derivative, that's going to be the acceleration. And then I think as an SL, you don't know how to take the derivative of this. However, there are derivative calculators in your GDC. So if I do second and calculate, there's the dy dx function. And then I want this specifically at a t value of 3, so I can just type in x equals 3 and press enter. So it's going to be 1.37. So 1.37 meters per second squared. And then we need to find the total distance traveled by the particle. So the particle travels from t is 0 to 6. So right here. And you have to be a little bit careful. So from t equals 0 to t equals 6, some of the area is going to be negative. So essentially, you need to split this up into the two portions, the one that's below the x-axis and the one that's above. And that's why we found out the intercept first. So it's at 0 at 3.92, so that's why we're splitting it off. Okay, so that was the negative part. So then I'm going to subtract that to the positive part, which is from 3.92 to 6. And again, we can just do all of this stuff in our calculator. And then I'm going to cheat a little bit. Maybe I can cheat. Okay, so this is my plan. Because I don't want to type all of this out here, which you can totally do in your graphing calculator. I'm just trying to be efficient, but this probably won't end up being efficient anyways. And this is not necessarily something that you guys need to know as SL students. But what I've done is I'm going to graph the absolute value of my velocity function. And the reason why is this is the exact same area as the normal one that goes underneath, but now it's positive, so that I can just do a straight up integral from 0 to 6. Which is a function in your calculator. So the lower limit is 0, upper limit is 6. So this area represents the total distance you traveled, which is 15.4 meters. So, or 0 to 6 of the absolute value. And that's something you can always do whenever you're dealing with a total distance. You can just take the absolute value and integrate that instead. And then on to the next one. Okay, Gary has a 50th birthday, so he starts to invest now when he's close to retirement. So he invests P dollars at 5% compounded monthly, find out, and then the amount of money at the end of each year is a geometric sequence, some common ratio, which we'll call alpha. Find alpha given your answer to 4 significant figures. So if you were to use the compound interest formula, which is in your book, the future value is the present value multiplied by all of this stuff. So if I plug in the right values, this is 5 over 100, and monthly, so it's 12, and then 12 t, where t is the amount of years. Alright, first question of the night. How do you know what a graph of a function's derivative looks like if they only give you the graph of the function? Okay, so the y value of your derivative, right? Because you're going to graph the derivative. The x value is going to be the same x value, but then here. So let's say that this is your function, right? Now, if you wanted to graph your derivative function at some specific x value, like right here, this has a tangent slope. And if you had specifics, you can calculate what the slope is. But we do know for sure that this is definitely negative. And let's just say that it's like -1/2. So that means that if we were to graph the derivative, that means that at this specific x value, we're going to graph the value of the tangent slope. So let's say that this is where -1/2 is. You put a coordinate right there. At this specific x value, the tangent slope is flat. So that has a value of 0. So when we graph the derivative function, it has a y value of 0 there. And then, you know, let's say you're over here. You have a coordinate on the actual graph. You can calculate the tangent slope there. Let's just say that that's +1. So that means that I can add a coordinate here. And then you just connect all your coordinates together. So your graph is this line. But again, if you have specifics, you can actually calculate slopes because maybe they gave you a graph and it has a proper grid, so you can calculate the rise and the run. But that's how you can... Doesn't have a grid? Okay, so then you're just quickly checking and making sure that they match. Is this like a matching question? Flat at the middle. And then it goes up on the right side, like straight line up. So flat in the middle, and then like this. And then down left side, like that. Something like this, maybe. Yeah, but smooth. And flat is along like this. Okay. So let's say that this is where you're going to graph your derivative. So what you do is you just compare some key slope values. So right here in the middle, the tangent slope through the center is 0, right? Because it's flat. So that means that we can add a coordinate with a y value of 0 at the x value of 0. And then, moving along, once you go past the center, your graph starts to slowly get increasingly more positive. So now it's slightly tilted upward. And then you move a little bit further along the x-axis, and then your graph is more sloped. You move a little bit further, it's more sloped. You move a little bit further, and then it gets very sloped. And then these are positive, so then you can kind of do a little sketch, and that it increases like this. Because again, as you move towards the right side, your slope is positive and it's increasing. And then look at this side over here. When I move a little bit away from the center, it's still positive slope. It's just very small. It's not very steep. And then as I move farther away from the center, my tangent slope is still positive, but it gets steeper and steeper. So on the left side, we also know that it's increasing. So then this is what the derivative should sort of look like. So hopefully that makes sense. Because this is I'm assuming this is a matching question, and they give you a bunch of graphs, and you have to pick which one is the derivative. So compare the tangent slopes, and then those are the y values of the derivative graph. Okay, so back to this one. This is our compound interest formula, and we need to find the common ratio alpha. And what we can do is we can find out how much is going to be in the account after 1 year, because we know that he has P, and then the next year he'll have some amount. And then of course, because it's a geometric ratio, we multiply that by alpha. So if we know what these two values are, we divide them to get alpha. Okay, so after 1 year, my future value is P dollars. And then I guess I can put this all in a calculator. So I'll deal with this part first. So 0.5, which is 5 divided by 100, divided by 12 plus 1. So that's that decimal. And so we have this decimal. And then I have no idea what question you're referring to. So you're going to have to be a little bit more specific. And then this is to the power of 12, and then this is for 1 year. So whatever this is, I guess I can just say 12. And then let's just actually find out what this value is. So I'm going to take this decimal and raise it to the power of 12. So 1.05. Okay, so in terms of the geometric sequence, this is U2. And if we know that the first term is P, right? So if I divide this by U1, which is P, I should get alpha. So alpha is this decimal right here, 1.5. Okay, so my student is asking for some help. So let's go search up what I gave them for work. Oh, congrats, 2 questions. So wait, this is function notation, right? Not this? Oh, RevisionVillage page 24, right, okay. That means I need to log into RevisionVillage. So let me just log in off screen, because I don't want you guys knowing my login. And then Serpent, can you wait? Oh, there's no numbers. Okay. Okay, so wait, not this window. This window. Yeah, there's 63 pages, but some of the questions take up 2 pages for an answer key. So there's not 63 questions. Anyways, so on page 24, right? So let's see. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 20. 1, 2, 3, 4. Is it this one? That takes more syllables. Okay, so let's see this question. So we have a diagram for the function f of x. And then we want to find out f of 1, right? So if we were to write this out, f of 1 is this. So first thing is you need to find out f of 1. So this is the y value when x is 1. So you can refer to the graph. So here's 1. The y value is here at 2. So that means that this becomes f at 2. And then you find f at 2. Okay, so we found alpha, and then Gary will make no further deposits. He's 50 years old and he just started saving, and he's not going to invest anymore. What is the derivative of 22x? Are you allowed to use derivative rules, Jazz, or do they want you to do this in like first principles or something, using the definition? You're allowed to use rules? If you're allowed to use rules, then you just use what we learned. So first off, well, it's multiple choice. Okay. Have you learned like power rule and stuff yet? Because if you haven't, then you probably shouldn't use derivative rules. Wrap-pupping. Thanks. Okay, you haven't learned them, right? So you have to use first principles, I think. So if your function is 22x, well, I mean, it's multiple choice, I think, right? Like, there's no way, or like, you just type in the answer, so it doesn't matter how you do it, but, I mean, I don't know if they want you to practice using the definition, or if they want you to just do it. Because like, if you just want to do it, then it's easy. Because square root 22 is just 22, root 22 times root x. Root x you write as an exponent. And then you just, you know, do the exponent stuff. So you bring down the 1/2. So now it's root 22 over 2. And then this becomes subtract 1. So it's negative 1/2. And then you can just, you know, write this as 22 over 2 root x or something. This is basic stuff. But I guess it's been like 2 years. Anyways, find the age when Gary will double his stuff. Okay, so I'm going to stick with the investment formula. And I want to find out when the future value is double the present value. So these would cancel. And, you know, that's why they intentionally don't tell you how much it is, because they're trying to show you it doesn't matter actually. And we're just trying to solve this exponential equation for t. And then this is, of course, whatever that... I shouldn't use a question mark. That's all of this stuff. Okay, so again, you can use logs, you can do whatever, but you do have a graphing calculator. So I'm gonna graph it. So 1 plus 0.05 divided by 12 to the power of 12 times x. And then I'm gonna change the window, and I don't know, I'm just guessing if he's gonna double his money in 20 years. It might not actually be true. So this is the time frame from 0 to 20 years, and then this is just 0 to 5 because I'm interested in when the y value is 2, so I don't need a crazy window. And then for the second graph, I just say y equals 2. And where they intersect is, of course, when he's going to double his money. So we can calculate that intersection. So first curve, second curve, and then TI-84s make an estimate. So 13.9 years. And then depending on the wording of the question, you might round down or round up. Okay. So find the age when the amount of money in his account will be double. So he starts at 50, right? And then 13.9 years pass, so he's gonna be 63 years old. Like half, 0.9 of a way into 63 years old. He's not 64 yet. Okay, making good time, I think. Okay, we have a bag, and it has 8 blue marbles, 12 green marbles, and some amount of red marbles. Marble is going to be selected at random and then put back in the bag. And then we do this 3 times. So write down the probability that the first marble we selected is blue. Well, that's easy enough. So the amount of marbles in the bag is 20 plus m, and there are 8 blue marbles, so probability of a blue marble, 28 plus m. Okay, next up. Let x be the number of blue marbles drawn. Find the smallest value of m such that the variance is less than 0.5. Okay. So, you have to note that x is binomially distributed. We're counting the number of blue marbles, so it's binomial. And then I don't have a formula book pulled up, so let me pull that up. IB Math Formula Booklet. And then let's go to statistics section. And then right here, we have a formula for variance. It's NP times 1 minus P. So we want the variance, which is NP 1 minus P, to be less than 0.5. Okay, and then of course N is the trials and P is the probability of whatever is happening. So probability of blue marbles. So in other words, the variance is 3 times 8 over 20 plus M, and then 1 minus P, which is again same thing, 20 plus M I mean, and we want to find out when this is less than 0.5. Okay, easy enough to do. We can just graph this function and then find out when it's 0.5, and then just find the interval when it's less than 0.5. Okay, before I do that, Jazz has her third question. At which point on this curve is the line parallel to this other line? Okay, so then you have like some graph, right? And then you have a line. And it doesn't matter where the line is, so I'm just gonna draw it here. If I could change colors. Like let's say here. So this is your line, and then this is your function. So somewhere along the function, there is a tangent slope that is going to be parallel with it. So maybe it's here. So in other words, f prime, the value of the tangent needs to be equal to the same slope as the line. So our line has this equation. So, you know, if you just switch the x and y's, this is slope-intercept form, right? So the slope of the line is 3, which means that when we take the derivative of our function, we need to make it equal to 3. So here's f, right? Then we take the derivative. So that's just going to be 2e to the x minus 3. And then this needs to be equal to 3. And then you can, you know, solve for x. So that means that 2e to the x is 6, which means that e to the x is 3. And that means that x is the natural log of 3. Now, this is just half of your answer because they want the point, right? They need an x and a y. So the last thing you do is you take this x value and then you plug it in for x in the original function, because that will give you the y value, and then you're done. So I'll just leave that up to you. When it says find the possible values of something, can I just use... Yeah. You can use inequalities. It doesn't matter how you answer, but you do need to know how to read interval notation, because the question might give it to you that way. Why? Because you have x. And then functions, right? If you plug in x, they give you y. And you want the point, so you need x and y. Okay, so as I was saying, I'm gonna graph this. So 8 divided by 20 plus x, and then 1 minus 8 divided by 20 plus x, bracket, 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 and then change my window. Okay, so here's my window. So x represents m, which is the number of marbles. So I'm gonna say that there's maybe 10 marbles. And then y value is the variance. So you can see it's 0.5, so I don't need a crazy y window. So it's just from -1 to 2. Okay, maybe I need to change my window somewhere. I think I put it in right. You know what? Okay, I'm not gonna deal with the TI-84 when I have this much better graphing calculator here. I wish I could let you guys use Desmos, it'd be way better. Okay, so I want to find out when this is less than 0.5. Oh, it doesn't let me do that. Okay. So y is less than 0.5. Okay, this is a little... Let me just change this to equal to. So here is your variance. It's this really thin red line. And then if I find out when it's equal to 0.5, which is at 17.8 marbles, any amount of red marbles past 17 results in a variance less than 0.5. So your marbles have to be more than 17. Oh, find the smallest value. Well, the smallest value is 18 then. Okay. Given f and g and h are functions with these specific values, and then we know their derivatives at those certain points, calculate the following. Question 1. Oh, something at 2, right? Okay. So we want to find the derivative of 3f plus 4h at the x value 2. So first off, we should just leave this as x, because you need to take the derivative of this. So essentially, because you have an addition, we can just take the derivative of each part. So the derivative of 3f is 3, the derivative of f. And then this is at a specific x value, or this is just the general function. And then likewise, take the derivative of 4h, well that's just 4 times h prime. And then we can evaluate this. So this wants it at the x value 2, right? So that means that we're finding the derivatives at f prime at 2 and then at h prime at 2. And the question tells you what these values are. So then the answer is 3 times whatever this is plus 4 times whatever this is. So you can probably take it from there. Okay, we're done this question. And then I think I move on to the longer ones. 1, 2, 3, and then I'm done. Anita has a question. Okay, Anita, well, you can type it in the chat or something. So meanwhile, I have this circle right here. And then I have all of these measurements, which I'm assuming are on the picture. Then I need to find AC. So AC... A to C is right here. And then note that it is part of this triangle. And we have 2 sides with an angle in between, so we can use cosine law to figure out what AC is. So this means that AC squared is 9 squared plus 12 squared minus 2 times 9 times 12 times cosine 108 degrees. So I'll calculate that in just a bit. Time to evaluate an integral. So we have an integral from 5 pi to 10 pi, and the integral is 6 sine x over 30 dx. Okay, so there's 2 ways that you can approach this. I think a little bit overkill, but a safe way is you do a u substitution. But you don't necessarily need to, because you should know what the integral of sine x is. So first off, the 6 doesn't do anything. That's just multiplied outside later. And the integral of sine x is negative cosine. And we know that it should be the same thing. X over 30. Now remember that when you take the derivative of this, you should end up back here. So the issue is, when you take the derivative of this cosine x over 30 part, there's a chain rule involved. And when you chain it, you won't get 6 sine x over 30. You'll end up getting 6 sine x over 30 times the derivative of the x over 30, which is 1 over 30. Right? So we don't want this part. You can't factor it out, it's inside the sign. So what that means is that the integral needs an extra coefficient of 30, so that this 30, when it multiplies with the 1 over 30 from the chain rule, they cancel out, so you do get the integral you need. And I'll show you the U substitution later. Okay, ignore this 30. You know the integral of sine is negative cosine. But, again, the integrand, this thing, we should get this when we take the derivative of what we have as our answer. And that's a good way to check if you did an integral correctly. But you see, when you take the integral of this, there's a chain rule, so then it multiplies by a 1 over 30. We don't have a 1 over 30 in our integral, which means there's a coefficient of 30 in the integral. Because when we do take the derivative now, this 30 is going to cancel out with this 1 over 30 from the chain rule. So this is actually our integral here. And then this you can just calculate yourself. If you don't want to do it this way, then there's U substitution. So you just let U be x over 30, which means that du is 1 over 30 dx. So then isolating for dx, you get dx is 30 du. So what happens to your integral is it becomes 6 sine u, and then there's an extra 30 from our substitution of dx. And then this is where the 30 comes in when you do it the u substitution way. Du. And then your boundaries of your integrals change, because this is for x, but we're talking about u now. So it becomes pi over 3, because 10 pi over 30 is, well, pi over 3. And then 5 pi over 30 is whatever that is, pi over 6. And then if you integrate this, well, you know the integral of sine is negative cosine. And then the 6 and the 30 multiply together, and we get the exact same answer. With slightly different boundaries, but that's because of our substitution. Why did I divide by 30? I didn't divide by 30 anywhere. Because these are for x. My variable is u. So I need to plug this into my definition of u, which says I literally divide it by 30. Okay, yeah, well, you did something that you can't do, so. Okay, before you get started, this is a degree question, so change to degree. And then I'm gonna put all of this into the calculator and then square root it. So let's see. 81, which is 9 squared, plus 144, minus 2 times 80, oops, nope, not 81, 9 times 12, times cosine 108. Non-real answer. How is this not a non-real answer? Alright, I guess I'm gonna try this again. 81 plus 144. Hello, Snake Star. And then 2 times 9 times 12 times cosine 108 degrees. And then I square root this. 17.1. So there's AC. Oh, Snakestar, what do you think of Ivy's decision? Because I think you asked me about the papers. They gave an option to schools. You either do the papers, or if you can't, then your grade is 100% based on your IA. Yeah, that's what happened last year. Alright, find angle DCA. In other words, I need to find out that angle right there. Now, what's nice is now that I know that this is 17.1 and its angle, complementary angle, let's say, corresponding angle, is 108. And I can use sine law to figure out this angle. Yeah, they decided for it to do it, and you don't mind it. Extended essay? Yeah, those are brutal. What subject did you decide to write it in? History? Oh, that's not bad. Better than math. Okay, so we set up sine law, and then we can just solve for the angle ACB through here. So I'm gonna inverse sine 9 times all of this stuff. So 30 degrees. Yeah, we're gonna do exams. Never gonna finish the package? Don't say never. I'll go through it on Monday. Oh, by the way, for those that are watching and those that are going to watch the video recording, my schedule is normally Thursday and Sunday for streaming, but, you know, Sunday is Valentine's Day. So, unlike maybe some of you sad suckers, I'm busy. So, I will push back my Sunday stream to Monday. Oh, RGPT, here once again. I don't think Max has made any progress with the Discord. Okay, so let's add this to the diagram. I know that this is 30 degrees. So again, not the Sunday, but Monday, the following Monday. Maxime, he's, yeah, he is. But he's, you know, a mod. And very enthusiastic about taking care of setting up things for me. Okay, then let's find the angle or area of ACD, so this triangle. Okay, easy enough to do. I should fail him. Yeah, you could have made a Discord, but I don't know. He wants to be all fancy with like channels and nitro and auto mods and whatever it is. Okay, we have a formula to calculate the area of a triangle. Not the base times height one, but for any triangle, if you know the angle, an angle. So let me just find it. Right here. So 1/2 AB times sine C. So I'm going to use the values that they gave me. She always has one. So here's a little hint. If you can use values that they've given you instead of your own values, then you should use their values just in case yours are messed up somehow. So the triangle of ACD is 1/2 times A, which is 9, times 12, times sine 108. So we can just calculate this. $51.4. And then, are there units? I don't think they're units, but whatever. I don't care about units right now. And then hence or otherwise, find the total area of the shaded region. So this entire region right here, right? Hence or otherwise, find the total area of this entire shaded part. Okay. Oh, okay. They do tell us the radius of the circle. So we need to just take the radius, or well, we just need to take the area of the circle and then subtract the two triangles. We already found the area of one triangle, and I just need to find the area of this triangle. How do you find the equation of tangent line if they give you the limit equation? What limit? Like the derivative limit? The definition of derivative? Okay, so while that's happening, we need to find the area of the second triangle. And we're gonna kind of use part B, and I'm gonna use this angle because I know that this side is 17.1 and this side 16, so I can do the same formula again. I know that their combined angles together is 75, so that's 45. So I just repeat my process. And then I can calculate this. So 0.5, 17.1, 16, sine 45. And that's 96.7. And then of course we add these together, and then we subtract them from the area of the circle, which is pi r squared, which is 9 squared. So let's see, that's 81 pi. Subtract all of this stuff. So 106. Okay. So, let's see. Assume f of x is continuous, and it is given to you that the limit as x approaches 5 of f of x plus 10 over x minus 5 equals 6. It follows that y is the equation of the tangent line at the point blank. Okay. So you need to recognize the format of this. This is more or less the derivative. And basically what you're saying is there's a graph, right? And then you have a certain x and y value. For example, 5 and 10. And then the definition of a tangent is you take the limit as you have a second point. So this point has the x value of x and the y value of f of x, right? So this is a proper slope because you have 2 points. So you take the difference in the x's or the y's, and then you divide the difference of the x's, like rise over run, right? So again, slope is change in y divided by change in x. In other words, you take f of x, you subtract 10, and then you divide x, you subtract 5, right? Now, if you want a tangent slope, essentially you take this point and then you move it closer and closer to the other point until eventually they overlap. Now, obviously it's impossible to calculate slope from one point because there is no change in x. You would divide by 0, but that's why limits are there. So essentially, the formal definition of a tangent slope, the derivative, is you take this expression and you find the limit as x goes to 5. So essentially, this is your derivative. So your question says y equals is the equation of the tangent line of f of x at the point blank. So the point is 5 and 10. Well, actually 5 and negative 10 because it was a plus 10. And then, oh man, the classic internet troll name, Skidmarks42069, has asked the question, and I'll get to it in a bit once I finish up here. Okay. Do you know what the function is though, Jazz? Because if you don't, then basically you know the point slope equation is y plus 10 is equal to all of this stuff. I have no idea who Skidmarks is. So this is point slope form, right? And this is technically the tangent slope. Hey, don't make fun of his name. Or their name, I don't know who it is. And then they want it y equals, right? So then you can just move the 10 over. And then that becomes minus 10. You can't do anything else if you don't know what the function is. So this is as far as it goes. Anyway, so Skidmarks42069 has asked, what do you mean the function is equal to 6? Just 6? Okay. The limit is equal to 6? Okay, so then all of this is 6. And then you just need to, you know, multiply the 6 in and then collect your numbers together, and then you're done. Okay, back to skid mark. Consider two different quadratic functions in this form. The graph of each function has the vertex on the x-axis. Find both values of q, and you can use a GDC if you want to. Okay. So there's a handful of ways that you can do this, skid marks. And then is this IB or is this a general question? Because if you're in IB, then there's certain ways that I can mention. Okay. You're not one of my students, right, skid marks? Maybe, maybe not. You probably are. Change your name. So embarrassing. Okay, vertex on x-axis. Find both values of q. Okay. So, I'm going to show you something. Shaming the teacher with that name. If your vertex is on the x-axis, imagine what this looks like. It'll either look like this, or maybe it'll look like this. Either way, how many x-intercepts does it have if the vertex is on the x-axis? This is just a fancy way of saying one x-intercept. So if we're talking about one x-intercept, then we use the discriminant, because the discriminant basically can tell us how many x-intercepts there are. So in other words, b squared minus 4ac needs to be equal to 0, because that's when you have one x-intercept. And you know what b, a, and c are, more or less, so then you can solve for q, knowing this stuff. So this is negative q squared minus 4 times 4 times 25. And then you just solve for q from here. Negative q squared is q squared, of course. And then this is just 400. And then I trust you can take it from here. You know what's weird? Never saw anyone ever use discriminant. Everything just required you to solve. Yeah, I guess. I mean, I remember using the discriminant for, like, differential equations. Isn't that a thing? Or am I confusing it for the Jacobian? But I guess the Jacobian of a 2x2 is a discriminant, isn't it? Of a quadratic or something? Yeah, I'm thinking of Jacobian. I don't know. I just remember that this showed up somewhere else, and I'm pretty sure it was differentials. But maybe not. I don't know. That was a long time ago. Wait, how do you find two values of q? Because you're going to square root q. Or you're going to square root 400. There's two values. Okay, did I finish this one? I did. Okay. It was critical points using determinant of the Jacobian from the R2 to the R2 map. Yeah. I guess. Okay, let's see. We have a square root function. And then we need to find f of 12. Easy enough. I can just plug it in. So that's 24 plus 1, which is 25. So f of 12 is 5, right? Okay, then we need to find the derivative. So I take the derivative. So here's my derivative, right? This is technically an exponent of 1/2. Make it a coefficient, subtract 1, multiply by the chain rule, which is 2. Let's see. Even in abstract algebra, you didn't need to get the complex roots to show that your polynomial was irreducible, but they still did. Instead, you could have used the discriminant, but you barely even seen quadratics in general. And I guess the root is always so easy to solve for. I guess there's no purpose in just saying there are complex roots instead of just solving for them. Yeah. I don't know. I just think it depends on the style of question, right? Like, show that there are 2 roots instead of solving for 2 roots. Because a very typical like quadratic question is like, you know, you have some unknown coefficient. And then they just ask you for what values of b does this polynomial have like 2 roots, for example. Then you can't necessarily solve for roots. Then you just need to use the discriminant, right? Okay, so then f at 12, or f prime at 12, well this cancels out, and then I already know what the square root of this stuff is when x is 12, so f prime at 12 is 1 over 5. One of those things that are good for in the beginning of math, yeah. Oh, so, by the way, RGPT, they introduced the gamma function very briefly to me in my Calc 2 class for my master's. They didn't really derive where it's from, but they were showing something about integrability of it. Just wanted to mention to you. Anyways, hi, this is my dumb question. Click the link. Do we have to do this? Can we just say this? Why do you multiply by 2 at the end of AII? Yeah, an extension to like complex numbers of factorial is cool. Anyways. So you need to find g of g inverse of 5, which is 5. I don't even... This is just part of your question, Amon Vincent. I don't know the context of this. But you could just say this, I guess. I don't know what this is about, to be honest. Why do I multiply by 2, Snake Star? It's part of the chain rule. Because what I'm doing, right, is I take the derivative of this thing. So this becomes a coefficient. And then I subtract 1, so it's negative 1/2. But then you have to multiply by the derivative of all of this stuff, which is 2. So hopefully that makes sense, why there's a 2 here. Okay, and then we have another function g, and then p is going to be a point on the graph of g. The x-coordinate of p is 12. The equation of the tangent to the graph at p is this. Write down g of 12. Okay, g prime of 12. So this is the tangent slope at 12, and we already know the equation of the tangent line. So this has a slope of 1, so the derivative is 1 at 12. Okay, good night. Good luck on your history. And then find g of 12. So this one's a pretty common one that people get stuck on, because essentially there's no actual expression for the function of g. But you have to also remember that a tangent line, the y-coordinate of the tangent line is also the value of the function of g at that specific x value. Otherwise, it's not touching the graph there. So I can plug in 12 into the equation of a line and get g of 12. So that's 15. And then let h of x be f times g, and then find the equation of the tangent where x is 12. So h is f times g, so if we want to find h prime, we use the product rule. So derivative of f times g plus f times the derivative of g. Okay, and then we evaluate this at the x value 12. So I'm plugging in 12 into all of these functions, and I'm assuming that I know what all of these values are going to be. Because I probably figured them out here, right? Okay, so let's see what we have. F prime at 12 was 1 over 5. G at 12 was 15. F at 12 is 5. G prime at 12 is 1. So then we can just, continue evaluating this. 3 plus 5, which is 8. Nice. And then the last one. So as I said earlier in the stream, this wasn't going to take me the entire stream. So when I'm done this, I wanted to move on to playing some more Baba Is You after I check and see how we did. Because I do know, at the very least, Jazz needs my help. Don't tell me to get the Discord up. You gotta tell Max. And I have no idea what he's doing right now. I don't think he's in the stream at this moment. Okay, so we have mass of something, and it's distributed normally, like so. And then here's the probability of your mass being in certain values. If you have a graph and it gives you points, how do you know which x values of f are not differentiable? Okay, there's three... Well, there's two reasons why a graph won't be differentiable. One is it's discontinuous. And then second, so here's discontinuous. There's three types of discontinuity. There's, asymptotic discontinuities. So let's say that this x value is at 2. By contraposition, continuous, non-continuous implies non-differentiable. Yeah. So you see, if it is discontinuous, then you don't have a derivative. So this graph is discontinuous at x equals 2. So it's not differentiable there. But there's different types of discontinuities. You also have removable discontinuity. And if you have piecewise functions, so something like this, this is discontinuous as well. So if you have any x values that happen at any of these locations, you're not going to be continuous there, which means that you're not differentiable there. Higgledy-flux. And then the second one is the limit of the derivative needs to exist. So when you have a graph and you have a function, just because it's continuous doesn't necessarily mean that it's differentiable. Because there's this sharp corner here, the limit of the derivative doesn't exist. So anytime you have a corner, sharp corner, I think it's called a cusp, you're not differentiable here. Because remember, limits need to exist from the left side and the right side. And if you find the tangent slope from the left side, that's the tangent slope. If you find the tangent slope on the right side, that's the tangent slope. They are completely different values for the slope, so the limit doesn't exist. Weierstrass function, continuous, nowhere differentiable function. Yep. There's also discontinuous everywhere, but something function, differentiable function? I don't remember. Or is it integrable function? The Weierstrass function. Yeah, Dirichlet. Yeah, so then these are the four situations, right? You have these three discontinuities, or you have any sort of cusp in your function. Doesn't Lebesgue integrable also mean Riemann integrable? I just had a question on this for my homework, actually. Yeah, we had a very guided example of showing that the popcorn function is the best way integrable. Anyways, back to this. Okay, write down the value of k. So then these are all the probabilities in your event. So they do need to add up to 1. So if you just do a little bit of thought, k needs to be 0.2. And then now we need to show that the mean is 165. Okay, now it's derivatives with trig functions. Okay. Emerald Tuna, thanks. Okay, RGPT's going off, but while he goes off, notice our table is symmetric, and this is a normal distribution. So because it's exactly symmetric, the mean has to happen exactly in the middle of 110 and 220. So I guess you would provide reasoning, right? Due to symmetry. And then you can even draw a nice little pick, right? The mean has to be right in between 110 and 220. So I'm assuming that that is what you get when you take 110 and you add it to 220 and divide by 2. Okay, Jazz has derivatives with trig functions. Are Darboux sums this thingy where you put the line on top or the bottom? Yeah, I learned about those. They didn't call them Darboux sums though. Anyways, hello, Co 9872132. What did they call him? I don't remember, to be honest. I think they just gave the symbology and they didn't even give them a name. Good to know, good to know. I mean, they defined them for us, right? Like, this one is like the infinitum of, you know, Riemann sum, blah, blah, blah. Yeah, infinitum over the partitions, and then the lower Darboux is the, like, supremum, whatever. Okay. So, Jazz says, what is G prime pi over 4 if f pi over 4 is -6, f prime at pi over 4 is 7, and g of x is f of x times sine of x. And then h, I'm assuming, is for a different question because that doesn't have anything to do with our question. Yeah. H is going to be very similar to G, so I'll just leave that up to you after we go through G. I wish I could be on voice. You can't be on voice, you're in chat. I'm the only voice. This is my channel. Okay, so we need to find the derivative. So this is a product rule. So I take f prime, and then I multiply that by sine. And then I take f of x, and then I multiply that by the derivative of sine. And then we want this at pi over 4, right? So then you just plug in pi over 4 into all of these and then do the math. Make sense, Jazz? You're being distracted by RGBT. Because they tell you what these functions at pi over 4 are. And you can evaluate sine at pi over 4 and cosine at pi over 4. Yeah, and then you do h in the exact same way. So I'll leave it to that. And then, did you guys notice that I had someone say hello to me and then their name was like in Hangul, all in Korean? Are they from Korea? Last stream or 2 streams ago I had a guy from had a person from, what was it again, RGPT? Do you remember? Indonesia or something? Oh, hello, Milky You. Milky You, I saw you at the grocery store yesterday. And I wanted to say hi, but then you were checking out. And I was also buying a bunch of instant noodles, so I didn't want you to see me. Last night. You went to self-checkout. Okay. Yeah, you did. I know you did. Your dad has long hair. I didn't expect that, if that is your father. I would've, but then like the moment I noticed you, it was too late. You were already going to self-checkout. Okay, so Emma Vincent has this question. Here. Okay, so this equation has 2 distinct real roots. So in other words, our discriminant, another discriminant question for RGPT, needs to be positive, greater than 0. And then we need to find the values of k so that this is possible. So in other words, if we just plug in all of our things, you get this. So basically, k squared needs to be larger than 4, or in other words, k needs to be larger than 2, or k needs to be smaller than -2, because when you square any of those values, you will be larger than 4. So, Amon Vincent, if you're still there, hopefully this makes sense what we did. Oh, I'm so close to being done my paper, and then I can play games while you guys ask for questions. Okay, so mean right here. Then we can find the probability that your mass is less than 120. Let's see. because, well, we have a graphing calculator. So we go to our distribution page, and then we have our normal CDF. And then we need to find less than 120, but that means we need standard distribution. Oh, okay. So to find this, we need to find standard distribution, because you see, I need to know what it is. So for part B, it's 5 marks. It's not your favorite, it's everyone's favorite. That's... this thing? This is the chain rule. Or not chain rule, product rule. Right? Derivative of the first thing times the second thing, and then the first thing times the derivative of the second thing. The derivative of sine is cosine. RGPT is such a snob. Okay, so for part B, we need to find standard deviation. What's... shouldn't it be sine? No, sine is the original function. You just do product rule on this. Product rule. Derivative times the second. Normal times the derivative of the second. Sine, the derivative of sine is cosine. You should review your product rule, Jazz. Yeah, it is. Okay, if we're ever missing standard deviation or mean, then we need to use standardized normals. What you buy at the grocery store, Milky You. So, we're gonna take this upper bound right here. And we are gonna standardize it. So in other words, this becomes the probability of your Z being less than 110 minus our mean, which we just found out. Snacks? Yeah, same. That's why I didn't want to say hi as well. I had like an armful of like instant noodles, so you know. Milk tea, milk tea. Oh. Teams is the online platform we're using at our school to like teach kids. But okay. No, the instant noodles weren't for me. I was buying them for our local history high school teacher, my colleague, because apparently she only eats like Mr. Noodle and like the like white people cheap instant noodles. So I needed to show her the good stuff, you know? Like Indomie, which she's never had in her life. I was so disappointed. Yeah. So I got her Indomie. Hopefully you all know what Indomie is. like the most famous instant noodle in like Southeast Asia. I got her Mama Tom Yum. This is really good, the silver packet. And then I also got her the really expensive Laksa one. That's like $5 a pack. I don't know if she has tried it yet. I don't think she's messaged me. She has not messaged me about it. And like, the reason why we got into this conversation is because her partner is like, he can't control himself around instant noodles. Apparently, like, when she was taking a break from cooking, he immediately went to the store and bought like a box of like Mr. Noodle instant noodles. And he ate them all in like a week. But you see, they're both white, so they have no idea what they're missing out on. So I needed to show them how good instant noodles could be. Anyways, so when you standardize stuff, it still has the same probability. But of course the boundary changes. We standardize the boundary. But this is good because you can inverse normal the probability to get the boundary. And then you equate that to your expression for the standardized boundary, and then you can solve for the standard deviation. Yeah, can you believe it? Never had Indomie. She ate like Maruchan and like, you know, no-name brand instant noodles. MSG is great. MSG, I think, it has a bad reputation. I'm not gonna lie. Basically, it was a racist smear campaign against MSG. And it has been proven that it has nothing necessarily unhealthy about it. Yeah, no-name brand. Like, I gave her 2 packs of no-name brand for a joke, and she took it home, and her partner got excited about them. And then he ate them instantly. Okay, hold on. Let me finish this, and then I need to check my team. I'm gonna deny this comment, and then I'll check it out. MSG's good. MSG's a cheat. If you want to make good food, use a little bit of MSG. Okay, so the areas of probability, and then when you do inverse normal in a TI-84 or 83, it's always an upper boundary one. And then our mean, well, it's 0 and 1, which is, you know, why we standardize this stuff. So -2.05. Okay, and then of course 100 minus 165 is -155, and then from here we can solve for the standard deviation. But anyways, yeah, MSG's good stuff. Don't hate on MSG. So our standard deviation is 26.8. Okay, so then I had a request to look at teams by, I think, Serpent. So let me just look at that real quick on my phone. I have no notifications about teams. Why are you telling me to check teams when there's nothing on there? Okay, next up was Jazz's question. For what values from 0 to 2 pi does this graph have a horizontal tangent? Okay, so horizontal tangents mean that your derivative is 0, right? So what you're going to do is you're going to take your function, never mind. Can you do this other one? 1 over t to the power 4 cosecant t plus 9. Does it look like this? Okay, that's fine if you can do both. Just take the derivative of this one, set it equal to 0, and then solve for x. It shouldn't be too hard. Okay, hold on. Before I do this harder looking one, which I need you to confirm if it looks good, Amont has asked me, do we have to make this table to show our work? No, you do not. It says give a full geometric description, so you do need to say what the transformations are, but you don't need to make a table for it. You can just say what they are. You were nominated as best TA? Man, they haven't seen you... They haven't seen you rant to me about your students on the stream then, because you wouldn't be... I don't think they would have voted you best TA if they saw what you were saying about them. So wait, Jazz is like this? Yeah, why am I doing my mod work when I have mods in my chat? Okay, so take the derivative of this. You can just Google how to take the derivative of cosecant t. But this is a product rule, right? So you should be practicing your derivative stuff. Take the product rule of these two things. You can Google what the derivative of cosecant t is. So try that out first. Okay. Serpent has asked a question. We have a function. It's piecewise. Mike. Yeah. Okay, so this question has, again, some prior learning. You need to know what continuous means, sort of. So basically, this function is split up into two parts. And I think I copied the question wrong. So let me just double check it. Okay, guess not. So at the x value 1, Serpent, when it's greater than 1, your function resembles this line. So 4x minus 1. So for example, basically it kind of looks like this. And then when x is less than 1, it resembles this parabola. So maybe the parabola looks like this or something. Oh my gosh, what's happening? help, who is this? RGBT is some like TA at some Albertan university, and he likes to hang out in my stream, in case you didn't know. But anyways, so back to this question, Serpent. This is considered discontinuous because the two graphs aren't connected together, for lack of a better description right now. So you see, if they did connect like this, then they're continuous. So in other words, you need to just see that when you plug in 1 into both of these, that they result in the same value, because then that means that they share the same point at 1. So just plug in 1, so then that's, 3. You plug in 1 here, and then that's 3, so then it's continuous. No, not really. It's not. They kind of got rid of limits, which is ironic. What do you mean, what? You need to show that when you plug in 1, that these two are the same. And then it is. Because, again, it's continuous, which means that you should be able to draw both parts of the graph without lifting up your pencil. So they need to have the same y value at x equals 1, which is where they split. Okay, kind of. Okay, I need to finish this up because I wanted to play a game. Okay. Any orange less than 120 grams is classified as small. It's the same game as like 2 weeks ago. No, it's the puzzle game. I refuse to play League, and I don't play shooters. I need something chill that I can, pause and then help out someone in chat when they need it. Still. Yeah, shooting my chat. That's different than shooting in the game. Because I hate aiming, and it's stressful. I play games to relax. Anyways, okay. Any orange with a mass less than 120 grams is considered small. Oh wait, I didn't even finish this question yet. I just found the standard deviation. So, now I can go back and find out the probability of my mass being less than 120 grams. Okay, so go to my normal CDF right here, and then my upper boundary is 120. My mean is 165, and my standard deviation, I just found out, is 26.8. Look, if I'm gonna... Oh, hello, squishing. Or squish GFX. But I keep seeing it as squishing. But anyways, if I'm gonna play a game, I do want it to be sort of math related. So puzzle games are the most natural extension because they require logical thinking, which is all about math. Well, then you plugged it in wrong. Okay. So the probability is 0.0466. Okay, so find the probability that a box of oranges selected at random has at most 2 small oranges. Wait, how many oranges are in the box? I guess it doesn't matter. Okay, so this is the probability of being small for 1 orange. So if the getting 2 small box... Wait, hold on. Oh, orange... Right here. Oh. Okay. There's 15 oranges in a box. And then we want to have the oranges contain at most 2 small oranges. So this is a binomial cumulative distribution, where we need to check 15 oranges, so then those are our amount of trials, and then the probability of each orange being small is this. So we just go into our calculator and do a binomial CDF. So 15 trials. The probability of being small is right here. And then we want at most 2 oranges. Oh, ooh, story time. RGPT says, at the help center today, a first-year physics student asked me to prove a limit uses... prove a limit converges using epsilon delta out of interest, and that redeemed my faith in humanity. Wow. Very impressive. Good job. Okay, so probability that you have 2 in a group of 15 is this. Actually, that's pretty high. So 9697. So 0.97. 97% chance you'll get 2 small oranges in a group of 15. If there's about a 5% chance of each orange being small. Okay, now we have a crate, and each crate has 20 boxes of oranges. Find the expected number of boxes in this crate that contain at most 2 small oranges. So this is at most 2 small oranges per box. So then the expected value of having 2 small well, you just take 0.97 and then you multiply it by the 20 boxes. So take my answer, times by 20. 19.4. Okay. Because kids usually come to the help center and then they ask for answers, and then this guy asks you to do it. Yeah, that's a good kid. I understand why you're happy. I'd be happy. Okay, find the probability that at least 18 boxes in this crate contain at most 2 oranges. Okay, so isn't this just binomial theorem again? At least 18 boxes. Okay, let's write this down. Y being at least 18 boxes means it needs to be like this. So we, unfortunately, in a TI-84 cannot find upper boundary cumulatives, but this is the same as the complement, which is 1 minus less than 18, which is 17 or less. So we can do that. That's easy enough to do. And then I'm done. So I'll just quickly check my answers, and then I can play a game for a bit. Okay, binomial stuff. How many boxes were there? The crate has 20. Call Max, you think I have my students' numbers? Okay, so probability 97.9. These numbers feel off. I probably messed up somewhere, but oh well. And then that is the end of this practice paper. So time for a quick check. Okay, so mark scheme. Okay, 16 students. 32 minutes. I think I have that. I can't see it. There it is, 32. 45. 45. This says 24, which I have 24, so that's good. Uh, 702, 702, 229, 229, 39, 39, 931, 931. Nice. This one was plus and minus 3. I had plus and minus 3. Okay, 3.92, 3.92, and then 1.37, 1.37, 15.4, 15.4. And then I'll get to your question, Serpent, after I quickly finish all of this. Okay, 1.051. I have 1.05, same thing. And then 63, he will be 63, so that's good. 18, 18, and then, oh yeah, there was PB of blue, which is over here. 8 over 20 plus m, 8 over 20 plus m. Okay, 17.1, I have 17.1. 30 degrees, that's right here, 30 degrees. 45 degrees, 45 degrees. 51.4. Where's my 51.4? Oh, right here, 51.4. And then 106. 106. Okay, 5. I got my 5. 1/5 is right here, 1/5. And then I have 1 and 15. I have 1 and 15, which means that the answer is 8. And then, oh, I didn't find the equation of the tangent. I just found the tangent slope. So that's 8. But then you can just find the equation real quick. So that's probably fine. And then this was the last one. Okay, 0.02 right here. hence using symmetry, so due to symmetry, 165, so that's good. And then find the standard distribution, and then, man, it sucks, you guys can't see this, so hold on. Because my chat overlay is there, but this is the answer, which is 0.064, or 46, which is what I have right here, so that's good. And then now I need to go back to the question. Okay, 797, 97, 19.4 boxes, 19.4 boxes, 979, 979. So, good job. Basically got perfect marks, which gives me an IB grade of 7, if this was a real paper. So I can close that. Close this, close this, close this, and then answer some more questions. Serpent, when it asks for gx for a transformation, can I write f of x plus 3 or whatever, or do I have to actually write the numbers? I have no idea what you're trying to say, so I can't tell you because I don't know what your question means. RGBT, why are you asking this in my chat? This might be a stupid question, but like, say you have an n-dimensional measure, which is n plus p homogeneous, is the measure of a, x, 0, whatever, blah blah blah, because of the dimension of the thing changing is 1. No, don't allow that word. We're not allowing that word. We've had this chat before. Hey. Oh my gosh, you had one job. Delete that. I feel like it's a dumb question. I don't know. I don't even know what you're trying to ask me. Yeah, delete the comment. That's a banned word. Yeah, I'm done. However, like I said, there are people that need help, so I'm gonna keep that running. But I'm gonna continue playing this game. I'm not gonna answer your question, because I have no idea what you're asking. However, I feel like this stage is difficult. So I can push the bolt around. The bolt will melt things. So, for example, it will melt the skull because the skull is hot. Page 32. Send me the question on Teams or whatever first. Oh, I just died. Okay, oh, Kiki is defeat, so this is Kiki. Okay, so space is weight. I don't know what space is weight means. Okay, so this is the plan. I can move the bolt to line up here, and then I change it so that it says that bolt is move. So the bolt will move whenever I move. I don't know what space weight means. Okay, so if I make the bolt move, now, oops, I don't want to go that way. How do I go back? It can go through Kiki because that's fine. Now the issue here is the bolt is melt. So if it touches the skull, which is hot, does the bolt explode? It does. So that's an issue. And then if I were to push the defeat so that the skull is no longer hot, now the skull is defeat. So if I touch the skull, I die. And then if I push it forward, then I break the sentence Baba is you, so I'm no longer Baba, and then I die. So what is the plan here? What happens if I time it so that we both go at the exact same time? Actually, but then the bolt will die. So I need this to... I want to break this sentence so that by the time the bolt reaches it, it can go through it. So... how many spaces is that? Not enough. So it's one thing behind. Okay, hold on. Let me time this right. So here it is as push. Yeah, I don't know where Jazz is. She said BRB, so... oh, there you go. See? Speak of the devil. Okay, so if I push this... but then this... oh, I can press up and it'll move forward. Yeah, so now the skull is no longer defeat. And then I can walk through here. And then I can push the win out. And then I just need to bring the bolt back, because the plan is I'm going to make the bolt the winning condition. Yeah. Okay, take a little pause, I guess. And then someone needs my help again. Two questions. Okay, let me turn on my pen again. That sounds just like you. By RGPT standards, you are. Very much so. Okay, so continuing this question. Part B says the graph of G is obtained by applying some transformations to the graph of F. So horizontal translation, 2 units to the left, followed by a reflection in the x-axis. So reflection in the x-axis, and then also a vertical stretch by a factor of 3. Okay. So there's 3 things happening, right? And essentially, if we were to use function notation, this is -3 times f of x minus 2, or plus 2, because you're moving to the left 2 spaces. That's brave of you, Jazz. Okay, but we don't want that. We want the actual function. So this is our actual function here, right? So let's just do this in parts. First off, I need this part, f of x plus 2. So f of x plus 2. Again, you should know what this means. That means that I'm plugging in x plus 2 into the original x's in my function. And then you need to multiply the functions by -3. So I multiply the entire function by -3, and this entire function by -3. And then depending on how far they simplify it, this is your answer for G. So hopefully that makes sense, Serpent. Okay, and then Amon Vincent says, for converting to vertex form, would you rather us use complete the square or that and then do that? It doesn't matter. It's whatever you like, Amon Vincent. Oh, I should change my title. We are now playing Baba is You. / math help. Twitch game. Nice. Yeah, whether you complete the square or you use the vertex formula stuff, it's fine. What? You asked him to help you. D high, D low, square the bottom, and away you go. What is this? Okay. Your function? Find the derivative. Just find the derivative. This is the same question I left you at. Like half an hour ago. So this is F, and then this is G. So it's a product, and then you can use product rule. So just take the derivative of each one. You should be able to do that. RGBT's so mad. If you say, oh, thanks, I get it, he's gonna be really mad. Because I just said the exact same thing. I'm glad you understand after I explained it. Okay, let's see what this is about. Okay, robot is me. Robot is stop. Water is sink. Pipe is stop. Wait, I'm robot? Whoa. And then water is sink, so obviously I would sink. And then the pipe is stopped, so I can't walk through the pipe. So let's see. I need to probably, what, sacrifice one of my robots so that I can walk through and create the sentence Baba is you, and then I can make Baba touch the flag. But the issue is there's nothing to stagger them in this stage the way it is. So essentially the puzzle, I think, is I need to find a way to stagger these so that I can walk one of them into the water without the other one walking into the water. And the only thing I really have to work with is this Baba to help me stagger them. Now, obviously, I could just push it like this, and now they're staggered. But this... Does this lead to a problem? Oh, I guess it doesn't. I can just make the sentence over here. I thought I would have... See, I was worried that Baba would be locked, and then it is locked, so I couldn't push it across. But I can just push across this one. There you go. Easy peasy. Alright, let's see. Baba is you and open. The water is stop and shut. So I open the water because I'm open and water shut, and then I die. Okay. And then I have key and flag, and then there's a flag right behind my corner. And I somehow need to get here and make a win, or take the win out. So let's see. If I make the sentence key is open, then I can use the key. Oh wait. There's no push word, so I can't even move this key. So let me see. Let's redo this. The only way I can move this key is if I'm the key then. So I need to make Baba and key is me. So now the key moves. But now neither of us are open, so I can't even open the water. I don't know. Maybe another 20 minutes or so. Because I've been streaming for about 2 hours and 40, so maybe round it off to 3 hours. You can't do it? Okay, what's the derivative of 1 over t to the power of 4? So this is t to the power negative 4. So then take the derivative. That's going to be a coefficient of negative 4. T to the power negative 5. So this is f prime. You also need g prime, which is the derivative of cosecant t. And again, I said that's something you can just Google. So go Google cosecant of t, and then you just make sure you put things in the right spot, right? Product rule is this, and you should know what all 4 of these things are. Let her answer when you ask. Yeah, you should skip to the harder questions. Yeah, and then you just put it into this formula. Okay, back to more pressing matters. How do I do this question? You don't need to simplify it. It just says find the derivative. It doesn't matter what it looks like. Okay, gotta use my brain more than I did during the papers. See, this is my plan. If I can open up this particular piece of water, then I can push the wind over, and then now I open this up so that I can come up and push it down and then out, and then I can make a sentence. Now the issue is how, if that's the way that you're supposed to do it, how do I get this? Because right now I'm the open, so I can open it up, but then of course, then I die. You got it right. You did. So I can become the key or the flag. But then I still die. I can become the key and the flag like I was doing, but then I use this word and then I'm no longer open anymore. So what do I do? Second derivative. Okay, I just gotta play with this, I guess, until I get some inspiration, because I can't quite see what I'm supposed to do right now. So let's play around with key. So if I say Baba is you and Key, then Baba becomes Key, but then I'm no longer Baba, so then I die, so I can't do that. I can always do like a share the is word, and then now the key is open, but the issue is there's no word push, so I can't even push the key. I walk right through it. So what can I do? Like the only thing that I feel like I have to do something like this. So now I am the key and Baba, but the issue is I'm no longer open. Unless I need to do some like some galaxy brain thinking. Because what happens if, like, is it possible that I can set this up in such a way that as I sacrifice something to open up the water, as I move forward, it changes the sentence so that I become something else, so that even though this dies, I become, like, let's say the key. Congrats. You're welcome. I don't know, you gotta study a lot. Okay, so some experimenting. I can break the sentence, and as long as I create a new sentence after breaking it, I don't die. But the issue is, I guess I can... I don't necessarily need to break it through this part. So let me see what I can do. if I don't mind. Yeah, it's easier than the game right now. Okay. So we need to find... This is a GDC question. So you can just graph this. And then you just look at the range for this specific domain. Ugh. Okay. Okay, I have some ideas. But I don't think they're gonna work. Nope, they're not gonna work. See, my idea was like, if I could put this in the water here, right? Then I can become the key, sacrifice myself, make an entrance, and then everything would be okay, maybe. But I can't do that. Why is this one so difficult? And unlike last time I played, chat is less helpful. But that's okay. I did get through one level at least. Or was it two? So I am both the key and Baba. I don't know if I'll be able to solve this particular problem in time. But because in terms of timing, I I'm going to try to cut it off at 3 hours. And I've been streaming for 2 hours and 57 minutes. So we're going to end the stream soon. So I think I have enough time to answer Serpent's question. And then maybe I'll call it there. So g of f of x is something. Three e to the power of x minus 6 plus k. And then given that you know when you take the limit as x goes to infinity, are you sure it's infinity? I don't think it's infinity. Or you typed in the wrong question. You went somewhere? Yeah, you're missing something. Yeah, negative infinity. Okay. So, in very loose speaking terms, x is going to go to negative infinity. So, for example, this is our only x value. So, you can consider this as e over, or 3 over e to the power of positive infinity minus 6 plus k. And again, you said that you know that this is negative 4, right? Okay. And then we talked about this. Very large number in a denominator means that this is very, very small. Well, not very small, but like very, very close to 0. Essentially, this whole thing is 0. Might want to let me change colors. So this we basically can consider 0. So then you have a very, very simple equation to help you find out k. Because it says that negative 6 plus k is negative 4, so you can find out what k is. Alrighty. 10 seconds left until I hit the 3-hour mark. So I think I'm going to call it here, guys. As I said earlier, but I'm going to delay Sunday stream till Monday. But please, you know, stop on by on Sunday. It's going to be a little busy because my class has a test Tuesday. So they're probably going to be spamming questions. Maybe. We'll see. But yeah, as I said, Sunday's Valentine's Day, so I don't want you guys, you know, watching Twitch on Valentine's Day. That's a little sad. So Monday, the day after. Get that Discord. I told you, I have nothing to do with the Discord. Yeah, find a girl, find a guy, find anyone, doesn't matter. But you know what? It's okay being single too. Don't measure your life and your success on your ability to be together with somebody. Be you. Be the best you. And that doesn't necessarily mean being with somebody. Anyways, with that, have a good weekend, you guys. And, oh, Jeremiah, you were here this whole time? You didn't even say hi. I'll chat with you guys later. So have a good weekend. Good long weekend.